I'm going to take what you learned yesterday about completion of the square, and we're going to use it to develop a little tool called the quadratic formula that most people choose to memorize and find pretty useful. Now we're going to start again by going back and looking at the general quadratic that you have right here. We're going to combine the x squared and the x term, and we're going to distribute out the a. Let me get my pencil here first. Now, in order to distribute out the a, we have to take the term that contains the b right there and divide it by. So when I multiply back through, I get an ax squared, and a times b over a will give me just plain a b. I've got a little bit of room for the completion of the square here, and then to eliminate the term that we introduce. Now there's the completion of the square. You can see the b over a, which is right here. It's been divided by 2, or cut in half if you'd rather. So you've got x plus b over 2a and x plus b over 2a. We find the areas of our squares. We've got a x squared, a b over 2a times x, b over 2a times x, and of course right here we get a b squared from b times b, and we get a 4a squared from 2a times 2a. This is the term right here that we needed in order to complete the square. So in that first blank, I put the b squared over 4a squared. It shows up right there. Now multiply back through, I've got ax squared, I've got bx, and one of the a's will cancel right here. This will be a b squared over 4a. So I subtract the b squared over 4a. Now the next thing I'm going to do is get a common denominator and add these two terms. So I multiply this c right here by 4a over 4a, and it becomes 4ac over 4a, and I subtract b squared over 4a. Common denominator right there is 4a. So now I've got my quadratic right here in vertex form, and that's what I'm going to use. I'm going to use the quadratic in that form right there. Now the purpose of the quadratic formula is to take a general quadratic, whether it's in general form or we've got it in vertex form, what we do right now, and to find the two roots. So I'm going to take, in order to find the roots, I'm going to replace the y with a 0 right here, and I'm going to isolate the x. Now the first step in isolation, the x, I have to add the opposite of this term to both sides. Now I'm going to take a look at that. If I take the opposite of 4ac minus b squared over 4a, I can just multiply through with the negative 1 right here. Matter of fact, I'm going to use negative 1 over 1, and that's going to become a negative 4ac plus b squared over 4a, and I'm going to add that to both sides. That'll get rid of this term right here, and it'll make this term negative 4ac plus b squared over 4a. Alright, now I'm going to write it now. On this side I've got b squared minus 4ac all over 4a. And that's going to be equal to a times a quantity x plus b over 2a squared. Now to continue to isolate the x, I'm going to multiply both sides by 1 over a. When I multiply this term by 1 over a, it becomes b squared minus 4ac over 4a squared. This side is now just x plus b over 2a quantity squared. Now the next step is going to be to take the square root of both sides. Now when you do this, you have to be a little bit careful. So you remember, you get two solutions. So I'm going to write a plus or minus. I'm going to take the square root of the numerator And I'm going to take the square root of the denominator, and you guys know the square root of 4 is 2, and the square root of a squared is just a. And over on this side, it leaves me with x plus b over 2a. And my last step in isolation of the x is to add the opposite of b over 2a to both sides. So I'm going to do that, and that'll leave me with just an x. And over on what used to be the left-hand side over here, I'm going to have the opposite of b over 2a plus or minus square root of b squared minus 4ac over 2a. I should extend my square root right there. Now, what most people will do, and I prefer not to do this, but most people will write this the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Now that's the quadratic formula, and that deserves to be memorized. And again, what we've done is we've just taken a quadratic up here in vertex form. We've gone to this next step down here, and we found the roots by isolating the x. Now you notice you've done this before. Matter of fact, you've done the same thing over and over and over again. Well, if you do the same thing over and over and over again, you can make it into a formula, which is what we've done here. And you got quadratic formula. Now let's use a quadratic formula that you see written up at the top of the page to actually solve an equation. The quadratic equation is written right down below here. Now the first thing I'm going to do is put this into standard form. So I'm going to rewrite. Get my pencil up here first. I'm going to rewrite this equation by subtracting 6 from both sides. So I've got 0 is equal to 3x squared. I'm going to write plus negative 5x, and it'll be plus negative 4. And then I'm going to identify a, b, and c. So the a here is a 3. The b is a negative 5. And the c is a negative 4. Now the toughest thing about using it actually ends up being this little subtraction right there. Probably causes more trouble than anything else. Now I'm going to put a negative 5 in for b. That'll give me a positive 5 right here. Then plus or minus the square root. I have to take the negative 5 and square it. That'll give me a 25. Then I'm going to subtract 4 times 3 times negative 4. And the whole thing will be divided by 2a, which is a non-issue right here. 2a will give me 6. So now I've got 5 plus or minus. Underneath the radical, I've got a 25. Subtract, and here I get a negative 16 times 3 is a negative 48. So it's minus negative 48, and that's what you got to watch out for. Divided by 6. Now I've got 5 plus or minus the square root. This is where I have trouble. I'm not a very good adder. And I think when you add those together, I think you get 73. And if it's not 73, then I've got some issues, and I'm done. I've got my value for x, and I probably should have written x is equal to all the way down the line here. I'll do that right now. But this number, or these two numbers, will satisfy that equation right there. So I really have two values for x. X could be 5 plus the square root of 73 over 6, or x could be 5 minus the square root of 73. over 6. Not very nice numbers, but you could certainly get a decimal approximation for them. And the first term there, that 5 over 6 that you see right there, it's first coordinate of the vertex. If you went back here and did what we were doing the other day, you just took the opposite of b and divided by 2a, you get that positive 5, 6. So there's a lot of stuff that shows up here. But that's quadratic formula, and that's how you use them.